Light is undisciplined energy. It is the result of the combination of many individual colors, each vibrating at different wavelengths to form the illusion of white light. While we find it hard to define the exact nature of light, we do know its exact speed. And because of this knowledge, we can compute distance accurately by measuring the time taken for a pulse of light to reach a target and return. Similar principles are used in sonar and radar, but the latent energy of light was left untapped until 20 years ago. Laser, light amplification by stimulated emission of radiation. The applications of lasers are extremely wide-ranging, from instruments that can cut and weld the toughest metals to lasers used in very delicate eye surgery. Australia is one of the leaders in laser research. We are among the 5 countries that have the necessary technology to produce a laser tube. Perhaps because of our vast distances, our research has been largely concentrated in the fields of communications, surveying, and land mapping.
Laser on? Laser on.
But possibly our most important laser development is our newest one. Defense scientists have spent 5 years developing an airborne laser, a laser to help study our seas, a laser to light the deep. Australia has the largest unencumbered continental shelf of any country on Earth. 6 million square kilometers. An ocean area so vast that surveys begun in 1807 remain incomplete today. Our chart makers, the Hydrographic Service of the Royal Australian Navy, have defined and made safe our main sea lanes. But many others remain inadequately charted. And with existing surface hydrographic techniques, it will take another 80 years to chart them. But Australia cannot wait that long. We are a developing nation and largely dependent on sea trade for our economic survival. Our ships and those of our trading partners, many of them giants of 100,000 tons with drafts of 20 meters or more, need quick and safe access to all our developing centers. Accurate charts are vital to this and every other nation's interests. Last year, throughout the world, 128 ships valued at $694 million were lost. Such disasters greatly influence the ever-increasing costs of freighting by sea, a cost borne by the consumer. There is an urgent need to complete our national charting responsibility as quickly as possible. But the task is too great for our sea-bound chart makers alone.
Stand by. Fix, center line. Port 10. Port 10. Very good.
Survey ships like HMAS Flinders need months, sometimes years, to chart comparatively small areas of ocean. The speed of gathering the hundreds of thousands of accurate water depth measurements is limited by the speed of the ship, 12 knots. But there are other limitations also. The ship cannot survey extremely shallow and dangerous waters, and specially equipped motor launchers have to be used.
End of line.
Roger, what's the new line?
1034 pattern 1, 250 to 350 pattern 3.
Roger, Flinders deliverance. We're running north to line 1034. Pattern 1 will run to line 1034. Flinders, roger.
In 24 hours, the ship has taken 480 readings but surveyed only 133 square kilometers of ocean and reduced the national charting commitment only marginally.
Stand by. Fix. Line 176, 198.7.
Better tools and more efficient techniques are required if completion of the task is to be hastened. And defense scientists, led by Mr. Mike Penny of the Electronic Research Laboratory, are providing them.
Back in the early 70s, the scientific advisor to the Navy and the RAN hydrographer, knowing of our activity in producing an airborne laser equipment to aid the Army for mapping or airborne mapping, asked the question, could airborne laser techniques be applied to depth sounding? The task was studied, overseas work examined, and after a few brief airborne experiments, we told the Navy we could.
Commence run 17, freedom out rate.
The result, an airborne laser depth sounder capable of making 168 depth measurements each second at a speed of 250 kilometers per hour. The system is undergoing its final trials before being brought into service with the Navy.
Check roll servo level.
Right.
Laser calling on. Laser calling flow.
Right.
Tape running.
Tape running. Tape's on.
Laser on.
Two laser pulses are simultaneously launched from the aircraft. An invisible infrared beam and a frequency doubled version of that pulse, which is green, the color best suited to penetrate water. The laser produces bursts of pure concentrated light, in contrast to normal white light, which is a jumbled mass of color with its beams spreading in all directions. The invisible red laser beam is reflected back to the aircraft from the sea surface, and the green beam penetrates the water to the seabed. Measurement of the time lapse between the surface and the seabed reflections allows the depth of water to be precisely calculated. Slow motion simulation illustrates the principle. But depth measurements are not confined to water immediately beneath the aircraft. Refraction and prismatic multiplication of the laser pulses enables a pattern of soundings to be taken simultaneously, and at the rate of 168 measurements a second, each precisely located and time-coded. The laser airborne depth sounder provides the most comprehensive analysis practicable. Further advantage is the ability of the aircraft to operate over shallow and reef-strewn areas where survey ships are at risk. But there are some disadvantages. The system is ineffective in dirty, turbid water and at depths greater than 50 meters. Defense scientists seek to resolve these problems, but despite them, the laser airborne depth sounder is a unique and extremely valuable hydrographic tool, and its potential is well known by the Navy's hydrographer, Captain Mike Calder.
The laser airborne depth sounder will provide the hydrographers of this world with the most productive coastal sounding system ever devised. It will have as profound an effect in the future on hydrography and charting as the introduction of the echo sounder in the days of the lead line. And that took place only 50 years ago.
The echo sounder is the prime tool of our seabound chart makers, but it will not be replaced by the new laser technology. The systems will complement each other. The airborne system can operate independendly, but basically it has been designed to work in conjunction with our survey ships.
Flinders, tester 18288.8 heading. Charlie 6-1, this is Flinders. Roger, we have you loud and clear. We're just going to the buoy. We have lost lock. Pattern 1 is playing up. Suggest you check yours.
By freeing them from the responsibility of surveying shoal waters, they will be able to concentrate their whole effort on deep water, where survey areas can be greatly enlarged and the ships more efficiently carry out their depth sounding and other charting responsibilities. Of prime importance is the navigational control system for the survey. The ship establishes and operates 4 land-based electronic navigational aids, which enable it and the aircraft to know precisely the position of each measurement taken. Without this vital information, the efforts of both are meaningless. But Flinders has other important duties: the recording of geographical landmarks and the monitoring of the tidal flux, both tasks beyond the capabilities of the aircraft. Tidal measurement is of great importance. It is essential chart information and vital knowledge for the mariner especially for those on large ships. For them, 10 feet or less water can make the difference between safe passage and disaster. Their safety is dependent on detailed and accurate charts, and our hydrographers are working hard to provide them as quickly as possible. Introduction into service of the laser airborne depth sounder will make them available even sooner. It promises to reduce the completion of our national charting responsibility from 80 to 10 years. New computer technology has been developed to support the system, and it will provide the charts to the world's mariners at the earliest possible time. They, the world's mariners, are the real beneficiaries of this revolutionary tool. A few years ago, the laser was described as an answer in search of a question. Australian research scientists have the questions, and the answers are not slow in coming. The laser airborne depth sounder will benefit all maritime nations, as well as making life easier for the world's hydrographers. Although it is a uniquely Australian development, the laser airborne depth sounder will help to light the waters of the world.